Hello, welcome to Unit 1, Day 11. Today we're going to be talking about box and whisker plots. All right, so this is a new graphical display of data that we're going to be learning about today that uses what we learned yesterday from the 5-number summaries. All right, so we're going to learn about the box and whisker plot, and we're going to learn about a modified box and whisker plot. I'm going to show you how to construct both of those using your TI-84 today, and we'll do a little bit of analyzing and interpreting of those box and whisker plots. All right, so recall from yesterday that we had test scores from our two calculus classes. So we have Class A and Class B, so these are the same sets of data that we used from yesterday's lesson. And I went ahead and copied over the 5-number summaries that we found yesterday as well for each class. And really, these are the pieces of information that we need to construct our box and whisker plot. Okay. All right, so box and whisker plot, just some things that you should know here. The whiskers extend to the minimum and the maximum data values. So there's going to be a box and there's going to be these whisker looking things. You'll see those when we draw our whiskers, they will extend to the minimum and the maximum data values. The walls of the box, right? So we're talking about the left and the right walls. Those will represent quartile 1 and quartile 3. You will only need a horizontal scale, so you'll see down here I've got a horizontal scale set up. This is really all you need because the vertical distance on this graph is irrelevant, all right? So how far above the horizontal scale you place things or how you space out the two box and whisker plots that we're going to put on here is irrelevant, all right? There's going to be an additional wall that goes inside the box that's going to represent the median. And this plot, as far as analysis goes, is really good for determining variability and skewness of the data. All right, and we'll talk about that in just a minute. All right, so let's get Class A. We're going to construct a box and whisker plot for Class A here. So we've got a minimum of 30, quartile 1. You got all the data here. So I'm going to start with my minimum. So well, actually, I'm going to start by putting a scale on this thing. So you might need to count out, like if we're going from a minimum of 30 to a max of 99, we need to make sure that we make each of these little tick marks on our horizontal scale a big enough number to where the entire box plot is going to fit on this scale. So I'm going to start at 30, make this my first value of 30, and then I'm going to go up by 5s. All right, so I've got my scale set up here. Now, notice I stopped at 115. I really didn't have to go up to 115 because I know my maximum value is going to be 99. So I know that this spread down here on the scale is going to cover my entire box plot. You also want to make sure that things are labeled. So tell the reader of your graph what these numbers represent. So this is going to be test scores. Okay. And I'm going to go ahead and start constructing my box and whisker plot. So the minimum is at 30. So what I'm going to do is just right here, some distance above the line. Doesn't really matter how far above the line you are. I'm just going to put a little vertical mark representing the minimum. And then I'm going to go to quartile 1 at 72.5. And so I'm just going to kind of eyeball it here in between 70 and 75. So at 72.5, I'm going to put another vertical mark about right here. And then I'm going to go to quartile 3. Right, quartile 3 is at 90.5, so here's that, and I'm going to put another vertical mark just like that. And then our maximum is at 99, so I'm going to come over here, here's 100, so we're just going to go a little bit before the 100, and I'm going to put one more vertical mark. Okay, so I'm going to close off my box. Right, so just by connecting those two, that's my quartile 1 and quartile 3, and remember, those represent the walls, the left and the right walls of the box. These are going to represent the end of the whiskers. So to construct a whisker, you just draw a line going from this right wall out to the right hash mark that I made. And I do the same thing over here on the left side. I'm just going to draw a line connecting that minimum to the left-hand wall. All right, the last thing that I need to add to this graph is my quartile 2 or the median. Right, and the median is at 80.5 for Class A, so that's going to be right about here. And I'm just going to put mark just like that inside of my box. Okay, so this is a box and whisker plot for Class A. So I'm going to label that over here. Okay, so now I'm going to switch colors and I'm going to do Class B. Okay, so So class B has a minimum of 33, so I'm gonna do the same thing, but I'm gonna do it right above my old box plot. So I'm gonna put it right here. That's 33, and then 72.5. So right there, and then 80 is the median. So I can go ahead and draw that in right now if I wanted to. And then 95. And then our max at 100. There we go. I'll close off my box. Remember, if you were doing this professionally, you would have rulers and stuff that you would be using to draw this. So mine is a bit sloppy since I'm using this digital pen. There we go. So now I've got both box and whisker plots. I'm going to label this with class B. All right, and now I've got a box and whisker plot for both classes stacked on top of each other. And this is usually one of the most useful ways, I think, to present your box and whisker plots. That way you can take a look. If you were doing analysis, you want to look at both classes at the same time. All right, so that's box and whisker. It's a pretty simple setup. And let's take a look at what a modified box and whisker plot looks like. All right, so for our modified box and whisker plots, so watch out for this word modified. The whiskers only extend to the last data value that are not outliers. So this is going to be where it's important to know your outliers. We are going to mark outliers on our graph here with a special symbol of our choosing. Sometimes they use an asterisk, sometimes they use a square or a triangle. It just depends on your preference, but you get to choose which special symbol you use to mark your outliers. All right. Again, you're only going to need a horizontal scale, and this particular plot is good for identifying outliers in your data. Okay. So here we go. We're going to do the same thing. I'm going to put the same exact scale that I had before, starting at 30 and going up by 5s. All right. So I got my horizontal axis set up. I labeled it. So I'm going to start with my leftmost, I'm going to start with class A. I'm going to start with my leftmost data point, which was a score of 30. So again, if you're wondering what I'm referencing here, we're referencing our 5-number summaries for class A and class B, and these are the original data sets here. Okay, so you'll recall from yesterday's lesson, we did identify 30 as an outlier. So I'm going to come over here, and for 30, I'm going to use an asterisk to represent my outlier. So there's my outlier. And then it says the whiskers extend to the last data value that is not an outlier. So if I'm going back up here and I'm looking at class A, we know that, oops, my 30 is missing from here. Oh. So my 30 we identified as an outlier. So I'm just going to cross it off real quick, and then I'm going to go to the next biggest data piece in my test scores for class A. Right, so that would be 67, nope, 66. All right, so 66 is the next biggest data piece. 66 was not an outlier according to yesterday's lesson. So I'm going to go to 66 here, and I'm going to place that whisker. All right, and then quartile 1 was at 72.5. And then quartile 2 was at 80.5. All right there. And then quartile 3 was at 90.5. And then our maximum was at 99. And remember, 99 was not an outlier. We figured out the outliers in yesterday's lesson. So if you need to figure out, like, how did we determine this was an outlier, we used that IQR rule that we learned about yesterday. All right, so I'm going to go ahead and seal off my box going from quartile 1 to quartile 3. And then I'm going to draw my whiskers. All right, so this is what our modified box plot would look like with an outlier. All right, so a little bit different. And a lot of times when you're dealing with data as a researcher or a scientist, you get to decide whether or not you include or exclude an outlier once you've investigated it and figure out, like, why did this outlier happen. You might want to have a good explanation for it. And then you decide whether or not we're going to include that in the data set or exclude it. But this kind of shows what your box and whisker plot would look like if it were excluded, right? Because this would be what it looks like, and you see a much shorter whisker over here on the left-hand side. All right. Make sure you still label this. I'm going to call this class A, and then we're going to do the same thing for class B. All right. So yesterday we figured out that the outlier for class B was the score of 33. So I'm going to go to 33 here, and I'm going to put my asterisks in there again. All right. This is for class B. And then I'm going to go back up to my data, and I'm going to scan for that next piece. All right. So there's the 33. And the next piece of data that is not an outlier looks like it's going to be the 68, unless I'm missing something. So 68. So there is my whisker. And then quartile 1 was at 72.5. The median was at 80. The third quartile was at 95, and the max was at 100. Okay, so I'm going to seal off my box, and then complete my whiskers. And there we go. And I'll label that with class B. So there is my modified box and whisker plot for each of those. And like I said, by doing this with the outliers, you see that the spread or the distance of those whiskers really shortened up compared to what we had up here when we just did a regular box and whisker plot that included the outliers. All right, and we'll talk about why that's important here in just a minute. All right, but first I want to show you how to do this on your calculator. All right, that way we're not drawing these things by hand. You can use your calculator to help you out. Okay, so to use your calculator, all right, you want to hit the stat button here, and you want to go to edit, and you want to make sure that your data is entered into L1 and L2, right? So L1, remember from yesterday, we let that represent class A, and over here in L2, we let list 2 represent the test scores from class B. All right, so you want to make sure you enter in your data first. Okay. Then what we're going to do is we're going to go up here to stat plot. You see the y equals button, and right above it in blue says stat plot. So I'm going to hit the blue button and then y equals. Okay. And I'm going to go to plot 1. So I'm just going to hit enter, and you'll notice that plot 1 is currently turned off. Well, I'm going to turn it on. Okay. And then it's going to ask you what kind of statistics plot do you want to do, and you'll see some options here. You actually see our histogram right there. The first option here, that's a scatter plot. This is a line graph, and then over here you have 2 different looking box and whisker plots. You'll see this one with the 2 dots. Okay, so let me get the cursor off there. This one has like those 2 dots on the end. That's a modified box plot. And then this one right here is just a regular box plot, right? And we just saw both of those constructed by hand. So let's do a modified box plot for each one. So I'm going to hit enter, make sure modified is selected. This one's going to be list 1, so class A, and then choose your special marker for your outliers. All right, so I'm going to choose, I think that's the asterisk, I can't really see it. There we go. And then I'm going to go back to stat plot, and I'm going to go to stat plot 2, and I'm going to turn that one on. Okay. And I'm going to do the same thing. I'm going to do a modified box and whisker. And this time I'm going to tell it to use list 2. So I'm going to hit second stat L2, and then I'm going to choose the same marker, just like that. All right, so now both stat plots have been entered in. You don't really have to do much more, but what I'm going to do next is hit zoom, and you'll notice there's an option down here that says zoom stat. This will automatically resize your screen based on your data. So this is going to make sure you get a nice scale down at the bottom. All right, so I'm going to hit enter. And there we go. You see our little dot over here. There's our outlier, and it's hard to see. Let me get a bigger screen here. It's one of the things that, oh, I still had something in there. Well, let me fix that. Let's go y equals. I think I had a function in there that I was analyzing earlier. There we go. Oh yeah, some log functions. Let's clear those out. Zoom 9. Let me get it back up here on the big screen so you can see our modified box and whisker plots. And you see they placed one right on the axis, and there's no way that I know of really to control like where they place the box and whisker plots vertically. But you can see here's class A, and this is class B down here. And you can see the little dots representing the outliers. Okay. And then if you click the trace button, another cool feature of this is if you click the trace button, it'll automatically lock a cursor on the important part. So if I go left, you can get right on that outlier. If I go back to the right, there's our next data value, and then quartile 1, quartile 2, quartile 3, and then our max. Okay. So pretty cool features. Calculator does this much quicker than if we were doing it by hand. So use the calculator. It's a very useful tool. All right, so last thing we're going to talk about just a little bit of analysis here. So we talk about questions that we can answer using the box plot. So we can ask ourselves questions like which class had more variability in the bottom 25%. So you have to remember how these box plots are split up, right? So this is, and we're going to go back up to our regular box plot here. All right, so you have to remember like this is the minimum and this is quartile 1. So this part of the box plot right here, that represents 25% of our data. All right, same thing down here. If this is the minimum and this is quartile 1, then this whisker, this left whisker, represents 25% of the data. So this is the bottom 25% for each. And since class A has a longer whisker, even though it's just slightly longer, has a slightly longer whisker here on the left, this would tell us that we have more variability in our data for the bottom 25% than class B does. And what we mean by variability is how spread out that 25% of the data is, okay? So for class A, that bottom 25% is more spread out, or it has more variability, okay? So then it asks, well, which class has more variability in the middle 50%? And we can actually use our modified box plot for this one too. So the middle 50% goes from quartile 1 to quartile 3. So the box itself represents the middle 50%. So you'll notice that class B's box going from quartile 1 to quartile 3 is bigger than the box in class A, which means the data values in the middle 50% for class B are more spread out. So class B has more variability in the middle 50%. Right? And this question right here, this is kind of a difficult one to answer with the box and whisker plot, but it says, which class do you think did better in general? And if I'm looking at these box and whisker plots here, it's kind of hard to tell. They had the same median score. The variability really doesn't tell you if a class did better or worse. It just means that their test scores were more consistent in different positions of the data. But really, they did very similarly. Right, we have this almost the same exact outliers. The boxes are, while one is kind of more spread out than the other, doesn't really tell us who did better. If we wanted to look at who did better in general, we'd want to see a difference in this median. That's definitely a good indicator for the test scores, but they're in almost the exact same spot. So it's kind of hard to tell, right? But you would talk about that based on what you see in the box and whisker plots. And we're going to come up with some other displays and some other ways of looking at the data to answer this question, right? Did class A or class B do better? And right now, my opinion is it's kind of hard to tell based on what we're seeing in the graph, right? It's not really giving me a clear picture. All right, guys, that's it for today's lesson. Give the practice problems a try and let me know if you have any questions in the Zoom chat. Have a great day.